Cast is now starting. All attendees are in listen-only mode.
Good evening, everyone. My name is Jay Parsons, and it is my pleasure to welcome you to this evening's webinar, Approaches to Enhancing Lambing Rate from Out-of-Season Breeding. This webinar is made possible with funding support from the Let's Grow Committee of the American Sheep Industry Association. We'd like to start by thanking them for their support of this webinar and to invite you to visit their website to learn more about the American sheep industry and to access some of the services and resources that they have there available to help you be successful in the sheep business. The URL for the ASI website is www.sheepusa.org. You can access the materials specific to the Let's Grow program by clicking on the icon on the homepage. I'd like to remind our listeners that this webinar is being recorded. All webinar registrants will receive a follow-up email within the next 48 hours with a direct link to the webinar recording, as well as a link to access the webinar slides. Links to these materials, as well as recordings and slides from our past webinars, are all posted on the Let's Grow website. We're slated for about a 45-minute presentation, followed by about 20 minutes of Q&A time. You can feel free to submit your questions at any time during the presentation or during the Q&A session by typing them into the question dialog box at the bottom of your control panel over on the right-hand side of your screen, or most people have it on the right-hand side of their screen. The Q&A session will also at that time allow you to ask questions of our speaker directly if you have a microphone attached to your computer, and you'll be able to do that just by raising your hand within the software. So we'll go over that again when we hit that portion of the program. So with those things out of the way, it's my pleasure to introduce this evening's speaker, Dr. Marlon Knights of West Virginia University. Dr. Knights is an associate professor of reproductive physiology in the Division of Animal and Nutritional Sciences in the Davis College of Agricultural Natural Resource and Design there at West Virginia University. Dr. Knights got his bachelor's and his master's degree at the University of West Indies before going on to West Virginia University to earn a PhD in reproductive physiology in 2001. From there, he did a postdoc for a couple of years at Michigan State, and now, as you can see, is on faculty there at West Virginia University. Dr. Knights is the author of an ASI Best Practices fact sheet on managing for seasonal changes in reproduction, and you may recall, some of you may recall that those fact sheets were subject of one of our previous webinars, and they're put out by ASI to help sheep producers increase productivity. So we're really pleased to have him here tonight to share his knowledge on this topic of out-of-season breeding. And he's coming to us from afar. Dr. Knight is a native actually from Trinidad and Tobago, and that is where he's coming to us this evening because he does a lot of work down there and actually holds a professor appointment in the biosciences and ag and food technology there at University of Trinidad and Tobago. So, Dr. Knight, we're happy to have you here this evening, and we'll let you take over from here.
Okay, thank you very much. Okay, good evening, everyone. And well, I should say it's about 9 p.m. here out in Trinidad, and just to sort of give you some perspective on where I'm located. Trinidad and Tobago is located right down on the coast next to Venezuela. So it's somewhere, some distance away from West Virginia, and, where, this whole topic of out-of-season breeding and is very much important. Not so important down in the tropics, just 10 degrees north of the equator, and so down in Trinidad, it's today, for example, it was 11.5 hours of sunlight. So on average, it varies between 13.5 and maybe 11.5 hours of sunlight each day. And today we had a low of about 83 degrees Fahrenheit. So actually a high of 83 degrees Fahrenheit. So this is a typical picture of one of the beaches down here, and I am sure no one is yearning to be out there in Trinidad. One of my favorite places in Trinidad is this area. It's a pool out in the ocean called an island pool, and hopefully on Sunday I'll be out there and thinking about the wonderful weather in West Virginia and further north. So this evening, it's my pleasure to discuss with you some aspects of out-of-season breeding, and in particular, approaches and ways by which we might be able to increase lambing rate in out-of-season breeding systems. I want to talk briefly about lambing rate as a measure of reproductive efficiency. Talk about seasonality of reproduction in sheep, really just to perhaps give an overview of some of the things you already know. Talk a bit about the consequences of seasonal reproduction, and then spend most of this evening discussing out-of-season breeding, some of the benefits and strategies involved in out-of-season breeding. So first off, I think most of us would appreciate that reproductive efficiency has a really large impact on the productivity and profitability of sheep operations. Perhaps it's the single most important factor when talking about productivity and profitability of operations. And lambing rate is really sort of a global measure of reproductive efficiency. There are a number of different variables, reproductive efficiency variables, estrus response, pregnancy rate, percent lambing and things like that. But lambing rate sort of gives a global view of how the flock is performing. So I want to just talk briefly and sort of remind us about this variable. So the flock lambing rate is really the number of lambs born per ewe. And I used this on the basis of per ewe exposed at the beginning of the breeding season. Not the number of lambs born per ewe lambing, but the number of lambs born per ewe that was exposed to rams at the beginning of the breeding season. The number of lambs born is really a function of the proportion of ewes lambing, what proportion of the ewes that was exposed to rams that actually lambed, and then the prolificacy, which is the lambs born per ewe lambing. So if we combine both of those factors, the proportion of ewes lambing and the prolificacy, then we can derive the lambing rate. So very quickly, if we introduced 100 ewes to rams and 90 of those ewes lambed, then the proportion lambing would be 90%. If those 90 ewes then produce 180 lambs, then the prolificacy is actually 200%. So 90 ewes giving us 180 lambs, or each ewe that lambed, lambed or gave birth to 2 lambs. The lambing rate, however, would be 180, the number of lambs that was produced, divided by the number of ewes that was exposed to rams. So in this case, the lambing rate would be 180%. Right. So it encompasses a number of things. So in order for you to lamb, it must show estrus, it must conceive, right? It must maintain that pregnancy throughout, and then it must give birth successfully. And then the prolificacy, as the term suggests, is that's the number of lambs delivered by each ewe that is actually giving birth. So if we look at the lambing rate in the US, this is somewhat of a dated figure, but I don't think it's changed very much. In the green bars really represent the lambing rate, and the lambing rate has more or less been steady at somewhere between 100 and 110%. So between 1 and 1.1 lambs born per ewe exposed to rams. And this is not actually the sort of level that we would think of as being extremely good. I think, if you look at some of the smaller flocks out in the east, you can get lambing rates up at 1.4, 1.5. And in some cases, in large, extensive production systems, these lambing rates could be somewhat less than the national average. So let's turn our attention to now seasonality of reproduction. So having this defined lambing rate. In temperate regions, not so much where I am at right now, but in North America, sheep are reproductively active during a very defined season. So if we look at this this graphic here and look at this sort of yellow area that is carved out, this represents for a typical flock the percentage of ewes that might be exhibiting estrus, and using exhibiting estrus as a measure of reproductive activity. So generally, the percentage of ewes exhibiting estrus, or that is in reproductive activity, would begin to increase in the fall months, in August, September, and perhaps peak in October, November, and then begin to decline. So it begins to decline in December, January, February, and in some cases by March, very few ewes are actually exhibiting any signs of estrus or are reproductively active. Right, and then this remains at very low levels until we go back into the fall months, August, September, October, etc. The timing of this seasonal reproduction is really driven by photoperiod. So the ewe measures day length. Right, and so it times the season of sexual receptivity, or the sexual season, to the period when they're very short days in the fall, and so the animals would be peak reproductive activity October, November, December, and then as the days begin to get longer, reproductive activity gradually ceases, and then the animal is said to be in a period of anestrus during those long days. So this is day length. As we increase day length, the animal is in anestrus, and as we get to the shorter days, the animal gets into a period of sexual receptivity, or what we often refer to as the breeding season. So again, we can look at another graphic, and we can look at this graphic, which shows again the percentage of ewes cycling, and then beginning in January, February, the percentage of ewes that are cycling would decline, and then after a period of time, perhaps in this particular experiment, none of the ewes was cycling from March to about July, and then during the shorter days, the percentage of ewes cycling increased again. Now, instead of looking, as researchers often do, they perhaps look at another way of measuring things. And one of the things we can look at in terms of measuring whether or not the ewe is having regular reproductive cycles, we can look at the secretion of a hormone. And in this case, oftentimes, we look at the secretion of this hormone referred to as LH, or luteinizing hormone. So the secretion of this hormone is relatively high during periods of reproductive activity. Then the secretion of LH goes to very low levels when the ewes are not cycling, and then reproductive activity, as reproductive activity begins again, the secretion of LH increases. So secretion of LH can be used as a measure of reproductive activity, and we'd utilize that in our discussion a bit later on. So what are some of the consequences of seasonality of reproduction? Well, one of the things is that it sort of confines the breeding season to one time for the year. And as a result, we can often have lower annual lifetime productivity of the ewe, since we were only probably going to get one lamb crop per year. We can also have significant variation in lamb prices, and we discussed this because reproduction is more or less confined to a specific season. That means breeding occurs during a limited time period. Most of the lambing occurs during a narrow window, and as such, a lot of the lambs would reach market weight during a narrow period as well, and as such, this can have a depressing effect on prices. There's also the impact of variation in lamb supply, and one of my old economics teachers once told me that to market things you need to have quality, quantity, and consistency. And so if you don't have consistency in lamb supply, it's very difficult to develop good markets. So as I mentioned before, the seasonality of reproduction results in very low lambing frequency, perhaps just one lambing per year in most cases. And this is really one of the major factors that limits lambing rate or productivity of the flock, and which in turn would reduce or limit profitability of the enterprise. Due to the seasonal nature of reproduction then, as I mentioned before, ewes would tend to be bred during the fall months, and we have this lovely multicolored butts of ewes here. When you use several rams in a particular group of ewes, and each of them having different crayons, you can have this very colorful butts on sheep. So these animals are going to be bred in the fall, and then they're going to lamb in the spring. And after lambing, these animals, maybe the ewes, would suckle for a couple of months, and then there's a long, what referred to as an inter-pregnancy period. There's not much going on there. Right? The ewe is not very productive. She may have, after lambing, she may have suckled for a couple months, 2 or 3 months, but thereafter, for the next 4 months, that animal is not very productive until she comes back into the breeding season, when she can be bred again. Now, this inter-pregnancy period is actually quite long when compared to other species. So for example, in cattle, one of the goals, if you're going to get a calf each year, then you probably need to get that animal from calving to pregnant again within 3 months. Even shorter if you're thinking about the case of pigs, perhaps anywhere from a month to 40 days after farrowing, you would like to get that sow bred back again. However, in the case of ewes, because of this long anestrous period, the period from lambing to rebreeding can be as much as 7 months. Another thing we encounter because of seasonality of reproduction is the sort of glutting of the market, where a lot of the lambs actually enter the market at the same time, and then you have most of those lambs being marketed at relatively low prices. So again, using our graphic, which shows the percentage of ewes, the line graph, the percentage of ewes that are in reproductive activity. Again, when reproductive activity is high, here's where we're going to breed our ewes. The ewes are going to lamb in the spring, and then after a period of grow out, those lambs are going to be marketed early fall and into mid-fall. So most of the lambs are hitting the market at the same time. This is some data going back from 1994 to 2001. I didn't really update it, but I think the pattern is going to be the same, where you see this peak in the amount of lambs that is hitting the market all in this fall period. And those of us who are into economics would appreciate that if we superimpose then a price graph on this supply line, then we would show that most of the lambs are then being sold at times when prices are relatively low. But there are periods in here when lamb supply is not as great and prices are actually pretty high. So this becomes one of the targets if you're trying to capitalize on those monthly price swings that we sometimes see. Some more recent data data for between 1990 and 2016. And this is looking at really the changes in price, monthly changes in price for slaughter lambs and feeder lambs. So we have the feeder lambs in the red line, and we can see that prices tend to be high up to about June, July, and then prices go very low. So this is a case for feeder lambs, and we see a similar pattern for slaughter lambs. And again, these low prices coincide with the period of high lamb supply, and then the relatively high prices, period of low lamb supply. So one of the goals of out-of-season breeding is really to try and to target those higher prices, get the lambs to the market when prices are higher. And if we look at an out-of-season breeding model, this suggests that during the period when reproductive activity is relatively low, few ewes are cycling, when we normally don't breed ewes, this is the time we are going to try to breed those animals. As the name suggests, we are breeding out of season. So these animals can lamb in the fall, right? And then perhaps be marketed when prices are relatively high. Another thing that the breeding out of season does for us is that it reduces this very long interpregnancy period, because animals can give birth in the spring after some period of time, perhaps 2 to 3 months. We can try to rebreed these animals during the Anestrous period so that they can again give birth into the fall. So we have reduced this sort of non-productive period, minimize this non-productive period. Therefore, we can benefit from increased annual and lifetime productivity of the ewe. So I think the big question then is, how do we get ewes to breed out of season? Their reproductive system have, in a sense, been deactivated. So what we need to do is really to reactivate that reproductive system, get the reproductive system of the ewe going again. I want to show this graphic again, and remember we said we can utilize LH, luteinizing hormone, as a measure of reproductive activity of the ewe, and that during the period, that Anestrous period, that out of season period, the secretion of LH is relatively low. Right? So LH can be utilized as a measure to determine whether, or to give us an indication of whether or not that ewe is going to be cycling. And if we want to get that ewe into reproductive activity, again, we need to do something that would increase the secretion of LH. So there are a few strategies which I think would make sense. The first thing is, if we're going to try to reactivate the reproductive system, we can perhaps make the ewe think it's fall. Make the ewe think that she is in short days, she's experiencing short days, or she's in the breeding season. So we can do that by light manipulation. This is a cheap, natural way we can expose that animal to periods of long day photoperiod, and then perhaps place those animals in a pen where they are exposed to very short duration of day length, and so that would trick the animals to believing that they are into the breeding season or experiencing short days. The problem with light manipulation is that it's not always practical. To hold a large group of ewes and exclude them for light for significant periods of time during spring and summer is sometimes not very practical. The other thing we can do to make the ewe think that it's fall is treat that ewe with melatonin. Say melatonin is often referred to as the hormone of darkness. So it's only secreted during the night, during when there's no daylight around, and so that photoperiod that the animal actually, in nature, the photoperiod that the animal experiences, that's transduced into a signal in terms of melatonin secretion. So that if the animal is exposed to a short day photoperiod, a lot of when day lengths are actually very short, then the animals are exposed to a long period of melatonin secretion. So there's synthetic melatonin that we can treat an animal with and get that animal to believe that it's experiencing short days or is in the breeding season. However, melatonin is not currently approved for use in the US. By far, the most frequently used method for reactivating the reproductive season is really the male effect or the Ram effect. And we talk a bit about this. It was discovered some time ago that if you introduce Rams to a group of ewes that is in Anestrous and that have been separated from the Rams for a period of time, the abrupt introduction of these Rams would stimulate the secretion of LH. Remember, LH is normally, prior to Ram introduction, if the animal is Anestrous, LH secretion would be relatively low. And if you introduce Rams to those ewes, then they would begin to show an increase in LH secretion, eventually really resulting in a surge in this hormone and ovulation. So, you can show a number of other researchers have shown that since. In some of the work that we did, we looked at secretion of LH in ewe lambs, and in red we have the secretion of LH in animals that were not exposed to Ram, and so you see LH secretion is very low, goes up once there and then goes back down. However, the yellow line represents secretion of LH that was in ewe lambs that was exposed to Rams, and you can see secretion is much higher, and you're getting this pulse of LH release much more frequently. And again, if we summarize all of that, you can see in the control animals that was not exposed to Rams, secretion of LH is relatively low, but when exposed to Rams, the secretion of LH increases. Actually, while all of this is going on, initially, if we are not taking blood samples and measuring this hormone, and we simply introduce Rams, novel Rams, to a group of ewes, what we might actually see and observe is 2 peaks in estrus activity occurring at about 17 and 24 days after the introduction of the Rams. But even before these estrus activities observed, other things actually occurred. So within 2 to 3 days after introduction of Rams to ewes during the Anestrous period, the out of season period, these ewes actually ovulate. At least some proportion of them would ovulate. But this ovulation is silent, so there's no estrus. There's no sexual receptivity associated with this ovulation. And what can happen is that the resultant, the corpus luteum, that structure that produces progesterone, 2 things might happen to it. It can be fully functional, in which case 17 days later, you would see estrus and ovulation occurring, and this estrus would be fertile. In other words, the ewe would be sexually receptive, and if she's mated, pregnancy can be established. or in some cases, after that first ovulation, the CL is not fully functional. You would get another ovulation, maybe about 7 days later. And then after a 17-day period, you can observe estrus activity in this group of ewes. So depending on the lifespan of the corpus luteum from this first ovulation, you can have ewes either showing estrus at around 17 days after introduction of rams, or about 24 days after the introduction of rams. So this is really the Ram effect. The Ram reactivates the reproductive system and induces ovulation and estrus in some proportion of the ewes. And really, perhaps if there's one thing I would like most of us to appreciate, is that the Ram effect is the key to successful breeding of ewes out of season. It's the thing that reactivates the reproductive system. And many of the other approaches that we use to improve lambing rate in out-of-season breeding systems is really based on harnessing and improving the Ram effect response. But getting a good Ram effect is going to be critical for getting a good proportion of the ewes getting pregnant and delivering a lamb in the fall. So some of the techniques we sometimes use to harness that Ram effect response include progesterone-pretreatment. So if we have dry mature females that is during that out-of-season period, during spring and summer months, we can pre-treat those animals with progesterone. And the way we often, what is most common is to treat these animals or apply a CIDR device to these animals. So again, I remind you of, if we just had do a introduction of rams, what you would observe is 2 peaks in estrus activity, one at about 17 and one about 24 days after ram introduction. However, if you pre-treat with progesterone, what we observe is right around between day 2 and day 3 after ram introduction, then we have a fertile estrus. So the ewes can actually exhibit estrus and be mated and establish a pregnancy from that ram introduction if we pre-treat with progesterone. And if animals do not conceive to this first period of estrus activity around day 3, then there's the opportunity for those animals to be bred at about 17 days after ram introduction. So big difference is, again, instead of having two peaks in estrus activity around day 17 and day 24, if you pre-treat with progesterone, you get a peak in estrus activity around day 2, between day 2 and day 3, and then perhaps another 14 days later. The reason this is occurring is because the progesterone pre-treated female is much more likely to express estrus as a result of some of the hormones that are induced by the introduction of the ram. And the progesterone pretreatment also prevents that short cycle that might occur sometimes. So the short cycle here is prevented by progesterone pretreatment. But here again, this is just harnessing the ram effect. The rams have introduced, and the rams stimulated really the ovulation. The progesterone is just sort of harnessing that and allowing those ewes to display estrus at an earlier period on day 3. This is actually perhaps also beneficial because the ewes can sometimes lose their responsiveness to the rams before that day 17 or day 24 period. And so by having the ewes exhibit estrus, right, the fertile estrus on day 3, this allows the ewes a better opportunity, more ewes an opportunity to become pregnant. So one of the basic treatment schedules that we have used for out-of-season breeding is simply treating those ewes, applying a CIDR for 5 days prior to ram introduction, then removing the CIDR, introducing the rams, and then, as I said, between 2 to 3 days after, those ewes should begin to display estrus. Typically, we would leave the rams in for about 26 to 30 days, so they get another opportunity. Ewes get another opportunity in case they didn't conceive at this first estrus. Maybe 14, 15 days later, there's another opportunity for them to be bred. Such a treatment often results in percentage of ewes lambing in excess of 60%. In this one experiment going way back in 2001, we simply looked at that progesterone-pretreatment versus ram introduction alone. And a few observations. One, the progesterone-pretreatment resulted in orange, resulted in about 20 to 25% more ewes giving birth, or more ewes lambing. Right? The prolificacy, the number of lambs born per ewe lambing, was not much different. But because we had a higher proportion of ewes lambing in the progesterone-treated, the CIDR-treated group, then the lambing rate was higher compared to simply just introducing the ewes to rams alone. And this graphic just depicts the pattern of lambing. So these 3 lines up here were the lambing pattern of ewes that were pre-treated with progesterone, and this is where the ewes were simply exposed to rams alone. Okay, so because of that first peak in estrus activity occurring around day 3, we had a greater proportion of the ewes lambing very early in the lambing period. Right? Then there's a plateauing of the lambing, and then these are ewes that would lamb as a result of the second estrus activity that might be occurring at about day 17 after ram introduction. In the case of the ewes that was simply just exposed to rams, you can see lambing begins much later in the lambing season, right, and is continuous. There are other things that you might have heard of, folks attempting to further enhance the response to out-of-season breeding. So, for example, some folks might try the use of PG600. So, in addition to the pre-treatment with CIDRs or progesterone, at ram introduction, you may administer some type of gonadotroping, such as PG600. And when we have done that in some studies, we see absolutely no benefit. Actually, the percentage of ewes that lambed actually went down in this one study from 72% if we just pre-treated with progesterone, compared to 63% if we pre-treated with progesterone and also gave an injection of PG600 at CIDR removal. When we came to lambing rate, there was no difference in the lambing rate between ewes that was pre-treated with CIDRs alone and ewes that were pre-treated with the CIDRs and given an injection of PG600. So there's no real benefit there. In other studies, actually, where we gave the PG600 1 day before the removal of the CIDR devices, we did see some benefit of using the PG600. But again, this is not consistent, and sometimes it really depends on the condition of the ewes. If it's likely that the ewes will not might not have given a good response to RAM introduction for whatever reason, the PG600 might might provide some benefit under those conditions. So there are a number of other things we can do to improve lambing rate in out-of-season breeding systems. First thing I would like to mention is breeding and selection. I think if we want to engage in out-of-season breeding, we need to choose the right breed. Some tropical breeds are known to respond well to out-of-season breeding. Other breeds, Dorsets, Polypays, Fin sheep, those breeds also respond well to out-of-season breeding. We also, within the breed, we have to select the right animals. The heritability for season length is relatively high, so that we can select for out-of-season breeding. And we can simply select replacement from ewe lambs born in fall. That's sort of quick and dirty way of selecting for out-of-season breeding. We choose our replacements from ewe lambs born in fall. There's also some evidence that you can benefit from heterosis, so crossbreeding, breeding the right animals, might also allow you to improve lambing rate from out-of-season breeding systems. Another management practice that should be attempted is to separate ewes from rams prior to the breeding period. Remember, it's the novelty of introducing a ram that was not in with the ewes for some period of time before would trigger the response. This response involves pheromones being released from the male, triggering release of hormones, including that hormone LH that we talked about, that would reactivate the reproductive system and result in ovulation. So if you do not have a good male stimuli, if it's not a novel ram, then this effect, the male effect, would not occur. So we have generally recommended separating the rams from the ewes at least 1 month prior to breeding. And again, this is because the ewes can become refractory to the ram. The ram no longer generates or stimulates that response. If you have some rams in with the ewes, it's possible one thing you would need to do is to introduce new or novel rams in order to evoke the response. Another practice we need to put in place to really improve our response to out-of-season breeding is really to take care of the ewe. Remember that ewe is the reproductive system of that ewe might be somewhat suppressed because of the season. So she's in the wrong season. Potentially she might be suckling a lamb or lambs. And she may, because she's suckling those lambs, she might have a low body condition score. So we also recommend, if possible, to wean lambs from ewes at least 1 month prior to breeding. And also ensure ewes are in a good body condition. So we can do this by improving nutrition prior to the breeding period. This is just a summary of one study in which we actually attempted to rebreed lactating ewes during the non-breeding season, so during that Anestrous period. And 2 things we looked at the effect of nutrition, if the animals was on a low plane of nutrition in blue or a high plane of nutrition in this orange color. And also with or without PG600. So whether or not the animals receive that injection of PG600, improving the nutrition improved the pregnancy rate. And when we use PG600 with improved nutrition, we got fairly good pregnancy rates. And these pregnancy rates are to just a single service, just one service period. And we were able to get pregnancy rates up to 50%. I must also mention that these ewes will range anywhere from about 40 to 90 days post lambing. So they were suckling, and they were between 40 to 90 days after lambing. A major factor that would affect the response to outer season breeding approaches is the ram power. We need to use a fair amount of rams. The ewe to ram ratio should not exceed 18 to 1. This is for two reasons. One, you want a good stimulus. You want the ewes to be appropriately stimulated. And also, the rams also exhibit seasonal depression in reproductive performance. So the semen characteristics, the sexual activity of the rams can also be depressed. So we want to ensure that we have good ram power. And in particular, if you are using pre-treatment with progesterone, because now you're synchronizing the estrus and you're having a large number of ewes coming into heat in those 2 to 3 days after the CIDR removal. So it's very critical that you have sufficient ram power. Another practice to consider is how we manage the breeding area. I like to recommend that we keep the animals in smaller lots for the first 2 to 3 days after ram introduction. And this is in an attempt to maximize the ram effect, to ensure that there's greater contact between ewes and rams. So keep the animals in relatively smaller lots so that the ewes are in contact with the rams. What we often see is, particularly sometimes after the initial introduction, since the sexual activity of the ram might be somewhat depressed, the female is an estrus. Sometimes the rams might tend to just commingle with themselves rather than getting in contact and stimulating the females. So by keeping the lots relatively small, you reduce the probability or the chances of those rams wandering off and not stimulating those females. The other thing I think we should avoid doing is avoid single ram lots. I know, in some cases we want to have a clear idea of which ram was mated to which female, but if at all possible, if that's not too important to you, then we should use more than one ram in the breeding lot. Again, this is just somewhat of trying to get greater contact, a greater ram effect, and also just a security, because as I mentioned before, some rams their reproductive activity would be somewhat depressed. So to detect those rams that may have poor reproductive characteristics of performance, low libido, or poor semen characteristics, then we need to conduct breeding soundness examination on rams. And this should be done whether or not in the breeding season or outer season breeding, but particularly in outer season breeding systems, we should conduct this examination on the rams and make sure that they are producing viable sperms. In some systems, the male is also primed. The male can be primed with melatonin treatment, prior to the breeding period. using Regulin or some other form of melatonin application that can improve the semen characteristics, improve libido, and as a result improve the male effect. So it can be either melatonin treatment, or it might be more feasible to actually use some type of light control for a few rams. So you can, while it might not be possible to place all the females in a light controlled sort of environment, but placing some number of ewes in a light control environment might be more feasible. And so that can be utilized in order to improve the reproductive activity of the rams, which would enhance the male effect or the ram effect. So the lambing rate, we said, is a function of the percentage of ewes lambing and the prolificacy. And so far, most of what we have spoken about is aimed at improving the percentage of ewes that are lambing. And some of them would also improve prolificacy. But if prolificacy is an issue, I think there are a couple of things we can look at. I think one of the easier approach to optimize prolificacy is through selection and breeding. I think breeding and selection is the cheapest and most practical approach. There's a lot of genetic diversity out there. Again, this is some data that is from Genovis, is a Canadian firm, and looked at collected data on a large number of breeds. And if you look at the prolificacy, you can see breeds with relatively low prolificacy, and you have breeds with relatively high prolificacy. And so by introducing some percentage blood from breeds with high prolificacy, we can address that issue. We can improve prolificacy in out-of-season breeding systems. In addition, other management practices that might try to optimize prolificacy include nutrition. Again, improving nutrition would not only result in ewes responding better to ram introduction, but can also enhance prolificacy, and also looking at the flock composition. We know that ovulation rate tends to be lower in the younger animals in your flock, and then increases. So having a good mix of animals, a good mix of parity in the flock would also aid in optimizing prolificacy. We mentioned that one of the primary goals of out-of-season breeding is to try to capitalize on those higher prices. But out-of-season breeding also provides us with an opportunity to improve annual and lifetime ewe productivity. It helps us to improve the consistency in lamb supply. In some cases where predation is a problem, there's data to suggest that out-of-season breeding, by shifting the lambing period from spring to fall, you have fewer losses to predators. And in general, all of these things can combine to improve profitability. I would like to just spend a few minutes talking about some of the opportunities to improve annual and lifetime ewe productivity from out-of-season breeding. So we can take even further advantage of fall lambing out-of-season breeding systems by rebreeding fall lambing females. So what we're saying is that if we are able to get those ewes to breed during the period of seasonal anestrus, out of season, these animals then give birth during the breeding season. And after a sort of short interpregnancy period, these animals actually begin to cycle again relatively early after giving birth. And so there's the opportunity for these animals to be rebred during the breeding season. this is some data where we did exactly that. We utilized 4 lambing ewes that were rebred around 70 days after giving birth. So these animals gave birth somewhere in October, and then 2.5 months later, we introduced them to rams using did some synchronization. And what we actually found is that these animals actually had relatively good lambing rate of around 100%. Which in this experiment was actually higher than our control animals, which in this case, our control animals were animals that were not bred or were not bred and did not lamb in that fall. So they had been open since the spring. But this control is probably not appropriate because these were animals that probably had some difficulty in getting pregnant in any case. But the major point, though, is that the animals that lambed in the fall after a period of 2 to 2.5 months can be successfully rebred. In this experiment, we use all the 4 lambing ewes were actually weaned, and they were all dry at the time of rebreeding. So we then asked another question, whether or not we can rebreed these 4 lambing ewes while they were still suckling. So here we have the lambing rate for ewes that were weaned and the ewes that were suckling when we started to rebreed them. And again, somewhat of an actual higher response in the ewes that were suckling their lambs during the rebreeding period. So very important, I think, in that we can really now begin to increase the frequency of lambing and further increase the lifetime productivity of the ewe. So just in summary, fall lambing can improve productivity and profitability if lambing rates are optimal, but achieving optimal lambing rates involves properly preparing the ewe and the ram for breeding. And again, both there are factors that we need to address in the ewe, making sure she is in a good body condition in particular. And again, with the ram, breeding soundness examination, good libido, a good amount of ram, so you have a relatively low ewe to ram ratio, no more than 18 ewes to ram. Also, the use of things like CIDRs and progesterone-pretreatment and other pharmaceuticals can assist in achieving optimal lambing rates, but we need to pay attention to that ram effect, so to that male effect. So this is just a few of the folks over the years that I've worked with, some grad students. Most of them have gone on to pretty successful careers now, but they were all part of some of the studies that I presented here this afternoon. So that's it, and thank you very much, and I'll be happy to try to address any questions.
Thank you, Marlon. That was great. A lot of good stuff there. We've had a lot of questions come in while you were talking, so I'll go ahead and start with a very basic one. And that is, we got a wide audience on here, and some of them are probably wondering, what is progesterone?
Okay. That's very good. Progesterone is what we often talk about as the hormone of pregnancy. But in a simple sense, the egg is in this capsule on the ovary, and once ovulation occurs and that egg is released, the remnants of that capsule forms what we refer to as a corpus luteum, and that corpus luteum produces this hormone, progesterone. It's produced in mammals, it supports pregnancy, but it has a number of other roles in reproduction. And as I mentioned before, one of the things that it does when we use it in out-of-season breeding systems is that it really increases the sensitivity to other hormones that makes the animal exhibit estrus.
Okay. And we had a couple of questions in, and I'm just going to read them both because they're very related and they came in right together. One of them says, what about using CIDRs and breeding 12-month-old ewes to lamb out of season? And then another person phrased it as, I noticed the data presented states mature ewes. Do these strategies not work on ewe lambs that would be bred at 11 or 12 months to get them into a fall lambing program? So
okay, and those are excellent questions. What we have consistently found is that ewe lambs do not respond as well. We tried to find out whether or not it was due to a lack of response to the ram. It wasn't that case, that most of the ewe lambs do respond to ram introduction with that increase in LH secretion. And what we did have to do and got fairly good response is actually adding some of the gonadotropin. So we actually got good response when we used the combination of CIDRs with some PG600 in some of the experiments. So it seems to be what we thought is maybe it's just a matter of the expression of estrus, because the ewe lambs would respond with the increase in LH secretion, they would ovulate, but they didn't seem to express estrus unless we added some of that PG600. But ewe lambs continue to be a bit is a bit more for a challenge than the mature ewes.
okay, and then we had one question came in that was on a specific slide, so I'm going to ask you if you can flip back to it. It was a slide right before you had the ewe ram ratio of 18:1. You had a slide of a trial there. This one right here. You just went past it. Go back forward.
Right.
There. No,
this one?
nope. You're too far back.
Okay.
Go back to where you had the 18:1. That one right there.
Oh.
Okay.
I think I'm going too far. This one?
That
this
one
line?
right there. Yeah. Well, the one with the graph.
Okay. This one.
Right there. Yes.
Yeah. Mm-hmm.
Okay. You didn't state on this whether this was with or without the CIDR. Was the CIDR a part of this trial? Was the question?
Yes, yes. This all the ewes had CIDRs, so all the ewes received CIDRs in this one. So what we did is we gave the ewes CIDRs. Well, first of all, let me step back. So half the ewes was on this enhanced plain nutrition, and then when came time to breeding, then all ewes got CIDRs, and then half of them would either get PG600, half would not get PG600.
Okay. Okay, that answers that question. Thank you. Okay, so I'm trying to get through these in a decent group. There was another question on the PG600. Will a higher rate of PG600 increase the number of ewes that lamb? And their example is a 5 milliliter dose. Do you want to talk a little bit about the dosage there?
Yeah. And this went even way back before we actually was actually some studies in goats way back when, and what I've found is that the 5 ml dose actually depressed pregnancy rates. I just found that was a bit too high, and there are some other studies. I think out of the University of Kentucky. I can't remember the exact study now, that also used the 5 ml dose and didn't seem to get as good a pregnancy rate. It's probably an overstimulation with that with that amount of PG600, and so we stepped back and have been using just 3 mls.
Okay. Let's see. There was another one. Can ewes be stimulated to ovulate with a high protein diet?
Again, it's really the Ram effect. Now, improving the nutrition of the ewes would enhance the response to the Ram effect, but simply improving the nutrition and not paying attention to the Rams and getting good stimulus wouldn't work. So we need to pay attention to the Ram effect in addition to those other things such as improving the nutritional status of the ewes.
Okay, and so a question did come in early on when you had the Ram effect in there, and that early, that first silent estrus, I believe was the term you used. Okay, the question was, does using CIDRs essentially cause the silent estrus to be skipped when Rams are introduced? And then does it follow that using teasers and CIDRs in the same group doesn't make sense then?
Right. We have not found any benefit in using the teasers if you if you use the CIDRs, because in a sense it doesn't, a silent estrus is sort of a misnomer, we always say, because it's either the animal expressed estrus or it didn't. What it is an ovulation without estrus, and what occurs is with pre-treatment with progesterone, this ovulation that I'm pointing to right here, there's now estrus with this ovulation. Right?
Okay.
So it's really a silent ovulation rather than a silent estrus, to be quite frank. And what the progesterone does is make the ovulation then occur with estrus.
Okay.
At this point in time.
Very good. So we had a question on the melatonin. You stated that melatonin injection is not approved in ewes, but then you stated that Rams could be treated with melatonin. Is melatonin approved for use in Rams?
I don't think it's approved for use. The thing about melatonin is that you can potentially go to the pharmacy and get melatonin. The reason why I'm saying using it in the males as opposed to the females, you're not getting any product out for the male at all, particularly if you're into doing things like, let's say, a dairy sheep production system where you may not want to introduce anything at all into the female, but you can use that to stimulate the male. But as far as I'm aware, melatonin and Regulin in particular, it's approved in Europe and things like that, but I don't think it's approved in the US.
Okay. Do you? I'm just going to ask this as it's worded. Do you believe in the ewe effect, that ewes coming into heat can bring other ewes into heat?
I think there's something to that. We have not. We tried to set up an experiment to test that, and we needed to repeat it again. But it's the feel of just from observation. I would want to agree with that, but it's just we haven't scientifically proven that to be so. But I think there's probably some thing to that. The more animals you're getting inducing to estrus, you always seem to almost see that. It's almost recruiting, like he was recruiting other ewes. But that is something for study. We tried to do it, but we weren't successful in the first replicate, and we never really repeated it, although we probably needed to.
Okay, related to that, I got to ask these because they're good questions. During out of season, will Rams that are introduced to a first group of ewes become more aroused and interested in breeding as more groups of ewes are introduced to the Rams during the breeding season?
Yeah, I think that is true. Once he is also activated and teased a bit, and that gets him going, and he's likely to be a little bit more aggressive with another group of ewes, right?
All right. You started off with some pictures of the beautiful weather down there. So somebody says, please discuss weather as it relates to out-of-season breeding. It's awfully hot in Oklahoma and Texas, and I imagine that could be a major factor.
Absolutely. A couple of things can occur in terms that can have an impact on just, again, the male effect and the percentage of animals that are ovulating. Where we also see effects is even if we get those those females bred, you may have an increase in embryonic mortality, embryonic and fetal mortality. So when come lambing time, you have less ewes lambing. So there are a number of different points. You can have impacts in terms of the quality of semen from rams as well. So there are multiple points where extremely high temperatures and prolonged periods of high temperatures will really decimate your attempts to breed out the season.
Okay. And keeping on with the ram, a couple people have asked about how far should the ram be kept away prior to reintroduction, and then somebody else about how much distance apart for best ram effect. Can you you mentioned the time, but what about the distance?
But I think it's in particular, it should be certainly the ram should be downwind, not upwind from the ewes. So you don't have, what you don't want is a distance where that ram, the scent of the ram, etc., is getting to the ewes. So it could be. I don't know a specific distance, but I would say as far away as is possible, and keeping the rams downwind so that that those ram scent is not getting to the females.
So then the opposite would be true in terms of trying to get the ram effect. They need to be close enough that they're getting the scent, right?
Right. So once you get the thing, I would say, get them in with the females and keep that keep the lots relatively small. So what you want is that ram paying attention to that females, harassing those females as much as possible to get a good ram effect.
Okay, we had a question on the Cornell University STAR program. What's your opinion of that for accelerated lambing? And you can say whatever. I mean, it's up to you how much you want to talk about it.
I think there's good enough data that if your management practices are in place and your nutrition is in place, that it can be utilized. Now that's really pushing it, and oftentimes it comes with weaning relatively early, and so you really need to have good management in place. And I'm not too sure, particularly if you're in an extensive type or semi-intensive type production system, how if the management will be compatible with that type of production system. If you're more in an intensive production system, certainly it can be attempted. But there's without going to the full Cornell model, but I think you can come close to getting about 70-80% of your ewes giving you 3 lambings in every 2 years. So 70-80% of your ewes giving you a lamb crop every 8 months. I really think that's possible.
Okay. And a procedural question: if using a CIDR, is the ram introduced on the day that the CIDR is pulled?
That is the model we have used, and we have gotten a good response from that. At the time the CIDR is removed is when we introduce the rams.
Okay. And a couple of questions on light treatment in regards to the rams. First one is there any benefit in giving only the rams a light treatment?
Absolutely. Again, what you're doing is really priming that male. I've seen both in goats and actually sheep, in goats and sheep, where just that priming of that male, there's enhanced activity, and you get a better response. So absolutely, if you can't prime all of them, you can't light treat all the animals, light treat the males, and that should enhance the response.
Okay, and then the second one is, can you describe a protocol for light priming rams for out-of-season breeding?
So There are a number of different approaches. I would say typically you're talking about 35 to 40 days either way. So you can have perhaps the simpler approach is to use the natural photoperiod in terms of the increasing day length as your long day, and then put the the rams in an environment where they're probably just getting 8 hours of light. And typically, if you can do that for about 35 days or so, you should be able to get the rams going. If you have the opportunity for both long day and short day treatments, again, about month and a half of long day treatment, followed by a month and a half of short day treatment. And the short day being 8 hours of light, 16 hours of darkness, and for the long day it's just the opposite.
Okay. Just kind of an off-the-wall question. How consistently will you use rebreed for fall lambing if the goal is to have a dedicated fall lambing flock and you are not just trying to reduce the rebreeding interval?
So what we observed is that once you get, you stick it at it, eventually you get a large proportion of your ewes breeding consistently in the spring. So you can perhaps get up, and when I say a large proportion, I'm thinking about between 75 and 85% of the ewes, breeding and lambing in the fall, if that's the approach that you want to take. But it takes some period of time sometimes to get off those numbers. But we have had producers who moved entirely to the spring or out of season breeding, combination of some changes in the genetics and just staying with the program until they were actually simply just turning out the rams. So they didn't do any progesterone-pretreatment or anything like that. So after 5 or 6 years, they were just turning out the rams.
Very good. Well, I know we're running out of time here, but I'm going to ask one more question. And I apologize to the people that didn't get their question asked. We had a lot of them come in, which is really good. So the question is, does suckling have a negative impact on out-of-season breeding? And I think you mentioned that at one point, but then when you were looking at I think they got a little confused by that last slide you put up, where they were fall lambing, and then you actually got more bred that were still suckling than those that had been lambs weaned. Do you want to address that a little bit in terms of that month period you were mentioning before?
Sure. I don't think the suckling effect is as much of a problem as is the effect of suckling in terms of the body condition of the animal, the nutritional status of the animal. So once we go beyond that 40, because we have to go, I think, beyond 40 days for you to have proper uterine involution and stuff. So once we go past 40 days or so, there isn't any major effect. Most of the literature would suggest no major effect of suckling on reproductive activity, unless if we take care of the nutritional status of the animal, and that is whether it is in out of season breeding systems or during the normal breeding season.
Okay, fantastic answer there. So anyway, again, thank you to everybody who sent in questions. We got a lot of questions, and I apologize for those that we didn't get to. And I want to thank you, Marlon, for a great presentation and for really handling those questions well. You got through a lot of them, so I really appreciate that, and I know our listeners do too.
All right, you're more than welcome. It's my pleasure.
Yeah, it's been great having you on, and I know that you got to suffer through the weather down there tomorrow. So
yes, absolutely.
So let's let you go and get some rest. For everybody that's on, we'll again, you'll be getting a follow-up email with a link to the recording, and then all these materials will be posted on the Let's Grow website. Marlon has already sent me his slides, so those will be posted up, and you'll have a link to that too in that follow-up email. And we thank you all for joining us, and we look forward to having you all on again soon for another one of these American Sheep Industry Association Let's Grow webinars. So thank everybody, and everybody have a good evening.